Welcome to springlib.
All right, so for this problem, we are given the two masses of the point particles that are attached at the two ends of the rod. We're given the mass of the rod. We're also given the radius of the rod. So we set up an equation for energy conservation. Initially, so if we set the reference plane with the zero gravitational potential energy to be along the rod, then initially there's no energy at all, no gravitational potential energy and no kinetic energy. Then the final energy of the system is, so object 1 obtains some gravitational potential energy, m1 gr, because it moves up. And so object 2 loses some gravitational potential energy by moving down. So it's negative m2 gr. And we have the kinetic energy for both point particles, which are simply 1/2 mv squared. And we also have the rotational energy for the rod, 1/2 I omega squared, where I, the moment of inertia for a rod with a rotational axis passing through its center, is 1/12 ml squared. And writing L equals 2R, this is simply 1/3 mr squared. And further, we can combine this omega squared and r squared into v squared. So this whole thing becomes 1/6 m v squared. So we observe that in this equation, everything is known except for this v's. So we can safely solve for v to get this analytical expression. And plugging in the numbers for all these quantities, we get v equals 1.46 meter per second.